Hi everyone, welcome to a video report for Chem 120 lab reviewing equilibrium. Let's get started. We will begin with part E of the lab. For part E, this is a reaction between iron and iron thiocyanate equilibrium. For iron, that is a transparent color as well as thiocyanate, and when reacted together, they produce iron thiocyanate, which is a very dark red color. This occurs because of how the thiocyanate ions and the iron 3 ions react with each other right here. For this part of the lab, there were a couple of different stresses placed on the equation. The first being heat. When heat was added, the solution turned to a lighter red coloration. We can infer that the solution color, or that due to the change in the hue of the color, the equilibrium shifted to the left towards the reactant side. This product's clear coloration will lighten up the red color, giving the solution a more orangish red color. This color change is also proof that the reaction is exothermic due to the lighter color being a result from the shift left, which means the stress was placed on the product side. The second stress added was double reactants. When added to the solution, the color turned to an even darker red. So double reactants right there. This is a result of the equilibrium shifting to the right to reestablish equilibrium between the products and the reactants after an abundance of reactants were added. The third stress added was the addition of AgNO3. From this stress, a white participant was formed, which is silver thiocyanate. This is a result of the thiocyanate being removed from the addition of AgNO3, which causes the reaction to shift left to the reactant side to reestablish equilibrium. This also results in a loss of the red color. For the second part of the lab, we'll review part A. The stress that was added is the addition of sodium acetate to the acetic acid. This stress is applied to the acetate anions, which causes the concentration to increase. This stress would result in a shift left, and this shift would also consume acetate anions to produce molecular unionized acetic acid. This stress and shift will further result in an increase of pH. This is from the decrease of concentration of the hydronium ions on the product side. The evidence proven was that there was a shift in the pH levels when sodium acetate was added to the acetic acid, which justifies how the equilibrium was established. The pH shifted from 4 to 6 when the addition of sodium acetate. For the final part of the lab, we will be discussing part B, which is between chromate and dichromate. Chromate is a yellow color, whereas dichromate is an orange color. And the original solution between the two of them is yellow-orange due to how the ions are in equilibrium with each other. For the first stress added is the addition of HCl. This adds stress on the hydronium reactants due to the HCl being a source of hydronium ions. This applies stress to the reactant sides, allowing for equilibrium to shift right. The addition of HCl causes chromate to react with the added hydronium ions, causing more products to form, which is dichromate, and this results in a more orangish solution. The next stress added was the addition of NOH to the original solution. This stress removes hydronium ions from the reactant side, causing the stress to shift left to form more reactants. Less dichromate products will be formed, resulting in a more yellow solution. The third stress is the addition of HCl to the NOH solution. This stress will re-enter hydronium ions, allowing for the solution to go back to its almost original equilibrium, and the color will return to yellow-orange again. And the final stress is the addition of NaOH to the HCl solution. This stress adds OH ions to the solution, which reduces the amount of hydronium ions, and this also brings the solution back to almost original equilibrium, and this will also bring back the color to yellow-orange. This is the references we use for lab. Thank you guys for listening, and I appreciate it.